Stephen, I think you're muted.
Stephen, can you hear us?
Yes. Can you hear me? Yeah, can you hear me at all? No?
Yes, we can hear you. I think you can hear me, but no. Yeah, I know that there is an echo. So I think maybe online you can hear the laptops, but not the microphone.
Yeah, big echo, yeah.
We were muted.
We were muted.
Now you should hear us. Is that correct?
Yep.
You can hear me. Yeah. Okay. So
So you can share the slide if you want, Stephen. So you can scroll down during your comments if you want.
All right. Can I share screen? Share screen.
Okay.
Okay. So yeah, so we collected in the document that we have, we've got our quite a number of ideas, comments, and thoughts all collected in the template. I think that's a fairly complete set of the discussion points. We thought not everything was decided by any means, but I think we see a path forward towards collating those and getting to the report. Good thing was when we separated, I thought when we separated into separate groups, discussion groups, the US side and then Europe, Asia, Middle East, Africa, we worked on those separate issues and looked at them separately. There was general convergence. And when we went back to the US document afterwards, we generally thought in agreement, and then we added stuff. So I think don't see big disagreements within our group, and I think there's there's a way forward. Obviously, the big uncertainty and what makes it difficult are the things that we are not in control of. So the uncertainty of the O5 performance and the true rate of compact binary coalescence. And Sheree's numbers there gave us a good indication. They're still uncertain, but we have to work with those. What's obviously more certain is if we have an event, what we do with that, the strategy. Igor's notebook was very useful to work with and get quick estimates of changing number of filters, changing the depth, and getting an idea on total required time. So that was useful, and I think that will be useful, very useful in writing the final report. Allows a quick optimizations of filter depth area and the time budget balance. So what do we need to do? The questions for us to answer here. Is Fabio going to take this? So that was the only thing I have really on the overview. And then we have to-do list. I see Fabio's name here. If he wants to take those, pretty happy.
Yep. No, you can stay there. We can, yeah.
Hello everybody, this is Fabio. Just to very fastly review the discussion from the BNS strategies. We had a discussion on to use 5 or 4 filters or involving strategies with different filters during the epochs from the first epoch after the trigger. The discussion focused on the use of the U-band when it is on the filter wheel, to use or change filters when U-band is not available. The filter, typically the filter when the U-band is not available, GRE for the 3 filter sets, or all the 5 without the Y-band, the Y band. Sorry, I just forgot how to say how to name the letter. So there was also discussion on how many nights to follow up the object after the trigger. The baseline scenario consider 3 nights as a bare minimum. But to help distinguish the kilonova from the other sources that will be contaminating the area. The discussion focused on the possibility to have also a fortnight to help the discrimination. We used it thanks to Shreya. We were able to have a reference number on the events based on the localization area performance of the from the GW side, and we consider as a gold sample, to trigger basically all the events within the 100 to 200 square degree with our optimal strategies, and we are discussing activation strategies that can evolve through time, thinking from what we can learn from the first part of 05, and then easy the constraints to trigger for also less well localized events if during the first part of 05 we won't use the time budget that we expect to. So the discussion is still going on, of course, and we were thinking to think about like a figure of merit to that can help us to have a cutoff for the activation of the trigger. So that's basically all. Thank you.
Thank you, Fabio. So regarding the neutron star black hole, me, Rafael, and Mansi, and Antonella, and also Clesio discussed about this yesterday. So thanks to Shreya numbers, we divided the kind of events. So in gold events, which would be well localized, so under 100 square degree. So we do some calculation also taking into account the paper of Igor. And so if we have 2 events per year, we need about 26 hours per year. So, and also for the silver events, we will need about 53 hours per year. So we discuss also about the scope plan. And so if we want to drop one of the 5 filters, so we need, of course, our to-do list for this kind of section is to have discussion about the strategies, so which filter we want to use or not. And so there is the document, the report in the first slide, so you can see all what we write down. And so if for the BBH case, Clesio, if you want to say something.
Hi, we discussed it, mostly myself and Antonella, about the BB8 scenario and what would be the best outcomes. So the hard part here is a different problem than the others, in the sense that you need to have a good association, right? Because flares happens all over the skies, and we require to be an AGN. So we focus on the very well localized, since there are many BBHs. So the idea would be to follow up only very well localized BBHs with 15 square degrees or less. So this would be 2 pointers for Rubin, which is not that expensive, but we need more visits. since we don't actually know when the flare is gonna happen. So we engage in the first part in the baseline to as soon as possible. So the first day, if possible. So we eliminate all the other active flares around the region and wait for the actual flare, right? You also select by the BBH masses, since we expect that the BBH flares are more likely to happen in higher masses BBHs. So making these cuts, we end up with the idea of following up to 7 events at a cost of 3 hours in total for 5 epochs, since they are just small, well-localized events. So, we still have a large to-do list. So there's this hard part of finding the transient on top of the AGN, which is a high surface brightness object. So you have to think a little bit about this and how to constrain better the when the flare gonna happen. So that would be our to-do list. So the strategy is minimal. This is just 3 filters, very well localized ones, so we can make an affirmative and positive confirmation.
Okay, thank you very much, Clesio. And so the last slide. Okay, so our program from today to Friday 12th is this one. So we decide to have our mid deadline when there will be the TVS MMA call, Pacific time, 9 Pacific time. So we thought that we could have a preliminary draft, thanks to the effort of everyone from us. In Tuesday, yes, in Tuesday, 26th of March. Then, of course, if we need to have Zoom call between us, we can do during these days. And the second call, in the second meet, it will be in the second TVS MMA call. And so we hope to have a matter draft sent out at 9 of April. And so in this way, me and Stephen will be the time, we will have the time to edit all the report for our science case, and in order to give a shape, a uniform shape. So the deadline is Friday 12, also if it is 14, but 14 is Sunday, so Friday 12, it's okay. And that's it. Of course, if there are comments, and we are here. And I want to really thanks Shreya for giving us numbers and for taking notes during these days for discussion, because they will be very useful for us, because they are on reports. So we will take note of everything you wrote for us. And also Antonella took the note for us. So, and thank you everybody for this big efforts in these days, because it was not easy to make this. So I thank you for the organizer, of course. Okay, thank you.
Thank you also to Hui for the great help
Yeah.
in managing downstairs, managing
Right.
the conversation, taking notes. So I would suggest an applause for her and Shreya for the work done these days. All right.
Yeah.
This was kind of also for you. Yes. And before opening the floor for questions, just to specify, in case you wonder what a TVS MMA call is, don't let fear of missing out overwhelm you. You have not missed out. It's an effort that Rafaela is going to start again. When's the first time again?
Tuesday.
On Tuesday, it will be at the same time of the regular TVS calls, which is going to be 9 a.m. Pacific, and will alternate with the cadence of the TVS call. If you want to participate and you don't belong to TVS, please reach out to me and Rafaela, and we will find out what's the best way for you to get involved. So we have a couple of minutes for questions. regarding the science cases that were presented, either in person or online. In fact, is there any question from online people already?
Yes.
Fed has her hand up.
Ah, okay.
Nothing online yet. Please use the. Nothing online yet. Use the key. For, oh, it's GW. Can you look at it? But I do have questions. I'm going to fill in the time until we read the online question with this. In the NS science case on the slides, you have a point on the 1000 square degree sources far. The bullet point says, how can we shift WFD to move normal survey footprint to cover map? Need simulations. Can you explain what you need and on what time scales so that we can?
Yeah, so I think so. This came from the discussion in the Slack and a bit in the discussion group. So, Thiago was suggesting, so if we got if you get something that's 1000 square degrees, maybe wider, instead of using TOO time to do it and defining a strategy, could you just shift what you would be doing in wide, fast, deep over the next few nights, just to that patch of sky, no cost as a TOO, but we just do it in normal survey operations. So probably that would need some simulations from Peter, and whether or not it's even feasible. I think Peter was positive in the Slack, but thought it would need to be looked at. There's obviously it's attractive to us overall, the project, because we don't take TOO time and we used wide, fast, deep in that way. But of course, it might impact on uniformity. It might impact on the other work that SCOC is doing with the science collaborations and trying with the rolling cadence to create uniform data releases. So I can see complications there, and that's why I put in need simulations.
Yeah, I understand now. Thank you. It's feasible, as Peter may want to speak, but it's entirely feasible from a technical perspective to add that as one of the features of the feature-based scheduler. To simulate it, we do need some more information, so we'll be in touch about how to integrate that in the simulation framework, I think.
Okay.
Are there any other questions? If not, let's hold on.
Something that I would like to see, this is Federica again, and something that I would like to see in the report that I haven't quite seen yet is how do we distribute these targets in time? How much time do we expect we want to reserve for targets during O5, which means, how many other targets can we take leading up to O5 and in preparation? We also want to, train the system and see that we are responsive. So we will want to take TOs before O5. But we need to know how much time needs to be saved for O5 to make a sensible plan to lead in there.
Yeah, you're right. Okay.
All right, so let's thank Sylvia and all the other speakers again.
Thank you.
Next up is Robert telling us about the discussion outcomes for the neutrino science case.
Yes, I was searching for to share the slides, but I don't find them. iPhone terminal, Mavic.
Has it been closed?
Yes, where are the slides in your? Yeah. Maybe we shut down. You destroyed my computer. Okay. Sorry. Okay. That's it. Real share.
Okay.
Okay.
Okay. Can people see this online and yeah? Yep. Okay. Okay, so let me wrap up summary of the discussion and all the work that we've been doing for neutrinos. So thank you very much, everyone who participated in person or online. So let me start with our timeline. This looks somewhat familiar. We actually already have a relatively mature skeleton, I would say. So much so that if anyone wants to provide comments right now, I think you definitely could look at the Google Doc and have a look at it. There are several open comments that we're addressing, but the kind of the bare bones there of what we would like to do. It's just more, the wording, making it sound a little more compelling, etc. So we're hoping to wrap that up soon, and we would like to have a mature draft ready to send around for final substantial comments by next Friday. And then we would anticipate giving people a week to provide comments for that. And then we will have a look at the final comments, implement all of the ones that we can. If there's any additional discussion that has to happen to really fully converge, then we reserve the opportunity to have a Zoom call. And also would very much like to be done by Friday 12th as well. So we're not trying to knock this out on a Sunday. So let me just recap kind of the very high level things that we would actually like to do. So trigger details again, for high energy neutrinos, we have IceCube right now. I would be extremely happy if the very first RubinTOO is a neutrino, because even during commissioning, this is ready to start triggering on immediately. So the rate is already there, but of course, over time, we expect these new neutrino observatories to come online as well. And as they do, we can revisit the number of triggers. So at the beginning, we would expect maybe 4 triggers a year, but this number can grow as you add another IceCube size detector. You can multiply the rate by 2 or 3. And again, what we'd like is just to be sure that we can cover it with a single Rubin pointing. So at least 70% of the contour with one Rubin pointing. That's going to get us a decent trigger rate and not be too expensive to the survey. What do we actually want to do when we do an observing? When we trigger on a, sorry. Yeah, okay. So what is our actual observing plan? So we try and be as cheap as possible, use as few observations as possible to get our science done. So one deep G observation, we put 120 seconds as a nominal exposure time, but of course on the basis of commissioning, if this is not performing well, we can definitely tweak it. And then we request very normal 30-second observations in Z and R, separated at least 15 minutes from the G band, but we're very flexible about, for example, if this happens 1 hour later or 6 hours later, whatever is most convenient for the scheduler, we don't have a strong opinion. On day 2, or day 1 in this numbering, we'd like another G band that's deep and a 30-second R. Day 7, we'd like G, R, and Z 30 seconds, and we'd also like 1 U band observation. I'm not sure how this is going to be possible to request, but basically, as soon as U band is available, we'd like 1 30-second exposure. So this might be on day 0, it might be on day 14, whatever is easiest, because U band is excellent for discriminating between different types of transients. So just to sum up, in total, we're talking about 7.5 minutes of observing time per neutrino plus overheads. And even if the rate of neutrino alerts triples with new detectors, that's still only roughly 90 minutes per year with overhead. So that's kind of roughly the odds for high energy neutrinos. Then we have the other science case, which is galactic supernova. And again, the take-home message is that this is a once-in-a-lifetime event potentially. So we should just trigger on whichever galactic supernova that we get. And yeah. There's not really much more to say on that. So there's basically 2 distinct phases. So step 1 is there's been a trigger, but we don't know where the supernova is. So then we're just trying to find the trigger. We won't know how bright it is necessarily. We don't know if we're going to be seeing shock breakout or when the shock breakout might occur. So I think we just basically want a sort of holding pattern. So maybe with I-band, for example, we'd suggest doing a mix of shorter and longer exposures. We don't know how big the localization region might be. It might be a single Rubin field, or it might be 10 Rubin fields. It really just depends. And the aim is just to find the localization. And as soon as we find it or anyone else finds it, we transition to stage 2, which is characterizing it. And here I think we really want to be making best use of Rubin specialty. So for me, I think that U-band is really the key strength here. So if U-band is available, it will probably be very heavily extincted, but Rubin may be the only telescope even that is capable of detecting a galactic supernova in U-band. So I think just hitting it continuously with U-band is a good idea. The other thing is, let's remember, if there's a galactic supernova, every single telescope in the world will be pointing at it at this point. We can't command every telescope in the world to do things sensibly, but at least within potentially like DECAM, for example, we can try and think of a sensible coordination strategy. So I think it doesn't make sense for Rubin and DECAM to both alternate between the same filters. So I think, for example, Rubin only doing U and say DECAM doing G or GRIZ, whatever, would make more sense. So we should definitely think about how best to avoid duplicating effort that is not useful, especially when we're talking about literally the same sort of observing site. And the other thing that we really need to stress is that this is just a basic plan. So the person who gets this alert sort of knows what to do immediately to provide some guidance, but there'll be information coming in all of the time, and this is going to be a very dynamic process. So I think what we really need to think about is the procedure for how these plans can be adjusted in real time, because they absolutely will need to be evolving over the course of the night and subsequent nights. So that's the other thing I'd like to emphasize. And that's pretty much it for the summary of the report itself. I thought maybe I'd just close on some broader discussion points that we had that maybe are of more relevance to the wider group as well. So in terms of structuring the report, we had a little bit of discussion with Adam, and we're very open to wider thoughts on this, but potentially we thought maybe high energy neutrinos and galactic supernovae are just better summarized as separate chapters, but if we want to combine them, that's also possible. We're open to feedback on that. One thing to think about in general is how a TOO will actually be conveyed to Rubin. So at the moment, for example, the neutrino localizations, the high energy neutrino localizations come in a GCN circular. It's not machine readable. A human has to read this and pass this. I expect that actually potentially the galactic supernova trigger would be the same situation. It's going to be like an ATEL or something, and it will just have some sort of written instructions. And we will not want to, on the night that a galactic supernova arrives, realize that there is no way to get this sort of thing into a Rubin TOO. So we're going to have to make sure that we're flexible in terms of accommodating sort of a generic, like text-based summary of a localization if we need to. In terms specifically of the galactic supernova, there are some concerns about how the system will be performing, because this might be the most extreme observation that we would undertake in the entire survey. So we'd want to do very short exposures, potentially 1 second. We don't know how many of them we can do before we start to stress the system, or we would like to have clear guidelines when you can do 10 or you can do X number, and then you have to give it a break. We also want to think about, for example, custom observing. So for galactic supernova, I can imagine that you really want to do dithering. And we would need an easy way of conveying this to the scheduler to make sure that this is what is actually happening, rather than just doing one field continuously. We need to really investigate how the DIA algorithms, how the data processing is going to work in very crowded fields. And also, it would be really good to understand how early we could trigger on a galactic supernova in terms of when we're still building up templates, what is possible when, and what would we do if we got this, during commissioning, for example. The other thing is that potentially, I'm not sure exactly how the oversight is going to work, but I think it would be good to have some people who are sort of specialists in this area on call. I think it's probably similar for other science cases, to provide input if needed on what the best thing to do is in a particular case. And the other thing is to do with TOO priorities. So obviously, most of you are interested in gravitational waves and you want to do your gravitational wave trigger. If a neutrino comes in on the same night, I would really like that the neutrino would also get observed, because we're talking about 5 minutes. I think you wouldn't necessarily even notice. But if the gravitational wave trigger is fully completed before the neutrino start, this would be very disruptive. So I think in terms of implementation, this is maybe not so straightforward, but it would be good to think about how these two science cases can sort of be interwoven in terms of an observing night, so that everyone gets the science that they want. And the other thing is how flexible we can be in terms of requesting scheduling. So for example, with neutrinos, if we want G, R, and Z in the first night, but it's already planned that later in the night we would do some R-band observing, for example, we would be very happy to not specifically say we want to do R-band observing at this time, but rather to integrate into the scheduler and say, wait until you're already observing an R-band and then just add this extra field. So these are some kind of provocative points maybe, and yeah, that's it. I'd like to thank everyone again who contributed to the neutrino science case, and hope you have some thoughts on this. Thanks.
Thank you, Robert, and everyone who contributed to the discussion. Question, Gotham?
I'm confused by this manual intervention stuff, because the neutrino alerts from IceCube and listeners can come over similar with Kafka, JSON packets, none of which, all of that's machine readable. Why do we feel that neutrinos need any kind of human in the loop?
So as far as I am aware, IceCube currently only reduces high energy neutrinos via GCN circular and notice, but the best localization that they have is a rectangle, and most sort of astronomy formats are not built to do this. So right now they release one localization, which is the best in the GCN circular, and then they release a second localization, which is known to be worse because it's circularized in the notice. I'm not sure what they are sending in Simma or if they're sending anything in Simma, but right now they don't have the capability. This is definitely something we could ask for though, because we're talking 2 years in the future.
So I think the bronze alerts from IceCube come through Simma, and you can ask Chris Weaver about those, but they are all JSON formatted packets. And even GCN is moving to GCN over Kafka in the next couple of years. So I would hope that nothing TO related requires some human to type in an array and a deck.
I mean, what I can tell you is right now in IceCube, if you want the best localization, you do need to do that. But I agree it's ridiculous and we should not be expecting to do this in the future.
In the room, we have a question from Raf and one from Fed. From Fed and then from Raf.
So one thing that I wanted to point out is that we had a hiccup in the organization of the meeting, and we ended up overlapping this meeting with the IceCube meeting in Europe. We are very sorry about that. And so we realized that we have limited presence from IceCube. So these kind of points, I hope that in the next couple of weeks, you can engage more IceCube people to make sure that we would look into these particular points, including like how they plan to improve their infrastructure in the next couple of years. And then one thing that I wanted to also highlight is, and Bob, correct me if I'm wrong, but when we think of a committee of people that would support the Rubin Observer for the TO program, we plan on this committee having a variety of expertise. So certainly all science cases that are already acknowledged as important and worthy of TO from Rubin, we would want to have people in the room that can speak to that. And yes.
Sorry, could I just respond to that point? Sorry, yeah. What I can say is also, I very much agree. It's great to get IceCube involved. Anna Frankovic was not able to join all of this meeting because she was attending the meeting. I actually asked her directly about this, and she said she was discussing it with the people in IceCube, and there's a very, very strong willingness to work with us. So
of the meeting. So
yeah, exactly. So the will is very much there to sort of like on both sides. I think we can make this work, but we just need to be clear in advance about what we need so that we have enough time to work towards making this as seamless as possible.
I just wanted to support what Fed said about the advisory group for the observer. I'm going to suggest that we start calling this person drawn from a group of scientists, a RubinToO scientist as opposed to observer, so we don't confuse people with thinking that we're tasking the observing specialists at night with this type of activity.
Hi, this is Raf. I have a question. So are you planning to use LSST according to your strategy even after we have identified and localized the galactic supernova?
So it would depend on the quality of the supernova, but if it's very extincted, then yeah, I would say if it's very faint in U-band and only Rubin can detect it, then Rubin should observe it in U-band.
Even if you could do it with something with smaller field of view?
No, only, so yeah, I kind of glossed over this. As soon as it's bright enough for other telescopes, we give up. I think Rubin is only useful, should only be observing when this thing is faint. Absolutely when it's bright light. If it's 17th mag, not Rubin's concern, in my
For
opinion.
smaller telescopes then, okay, I got it.
So we have a couple of questions from people online. I see Mansi has their hand up and Tony as well. So let's go with Mansi first.
Hi, so I just wanted to say that I think this neutrino science case is very compelling scientifically, and it also has the effect of being excellent training wheels for any other TO science that people are interested in later, right, be it GW or anything else. The two sort of technical questions I had for Robert was one was on the high energy neutrino case. You have the longer exposure in G, but on day 7, you go back to 30 seconds. Why is that? Why not stick to 120 seconds so you can actually follow the evolution for a week?
So we wouldn't be strongly opposed to having a second 120-second exposure, but the motivation for having it in the first place was on day 0 to get a very deep data point to constrain a rising supernova that might appear later, and on day 1 to constrain something that's fading very rapidly. So kind of the logic was, if it wasn't rising extremely, so if it was not fading extremely quickly, we would probably still be able to detect it in one of the filters on day 7 and have 2 early detections. But if it's easier for processing, of course, we could do 3. But I think, you know, two is the minimum that we need to do the science.
Yeah, I'd urge you to consider changing day 7 G-band to 120 seconds as well, so that all 3 points, it's only 3 points on the light curve, right? And all 3 points have the same fidelity and depth. In case something is fading between day 1 and day 7, then you wouldn't want it to be a non-detection and a shallow upper limit that doesn't constrain the light curve. There is enough diversity in the models that I think that it might I just encourage the group to think about the G-band 120 on day 7.
Yeah, thanks.
And
that's an excellent.
the other question I had for you was on the galactics supernova slide. What about at very late time? So you're talking about very early time, but did the group discuss what happens at very late time, when again the smaller telescopes and the rest of the planet can no longer get very good data, but Rubin possibly can again contribute more uniquely in the very late phase of a galactic supernova? Was there any discussion of that?
There was definitely discussion of that. That is an excellent question. So it's maybe a question for what is the scope of this plan that we're proposing, because we're sort of emphasizing that we think the plan should be adjusted as information emerged. And the thought was that basically if there's a galactic supernova, we need a day 0 plan. If we want to do on day 70 or 100, when it's very faded, there would be plenty of time after the galactic supernova had actually been discovered to decide what would be an appropriate late time strategy. But we can definitely put in a nominal late time strategy as well if that's useful. It's kind of just a question of what this specific observing plan should cover in terms of phase.
Okay,
Tony?
thank you.
Adam, sorry, is this relevant to this point? There is a Adam who was this in the room. Is this a separate one? Okay, then let's catch it later. Thanks. Tony, would you like to go ahead?
Yeah, I think you answered my question just recently, but I don't see any reason for using Rubin once the source has been identified to an arc second. There'll be plenty by this time in a few years. There'll be plenty of telescopes in the south that could cover that to quite faint magnitudes. You just have to integrate long enough.
I think the U-band sensitivity is the real killer compelling argument, in my opinion. I'm not sure if, for example, DECAM has U-band, I think not.
Yes.
Oh, it does.
Yes, it does.
Oh, it does.
And there will be more telescopes with U-band.
Okay, well, in general, I would say we should just see if there are any, so we should just see if there are any sort of ranges where only Rubin can observe. As soon as other telescopes can take over, we should be very receptive to letting them do so. That's my kind of core point on this once the counterpart has been identified.
Yeah, thanks.
Black will also have U-band. Adam.
Hi, I have a comment about this, but sort of a general comment for everyone. A second ago, you showed on the slide that you want TOO observations 7 days after the event. I suspect that there's nothing special about 7 days. 7 probably equals 6 equals 8 equals 10. And I would encourage all science cases, not just neutrinos, that if you're looking for something on a week-long timescale, that is probably best done via a reweighting of the priorities in wide, fast, deep. And I think Ryan and I wrote that in for the burst with GW, but that's probably true for anything, right? TO specifically is an interrupt. 7 days later, I don't know that you need to say stop whatever is otherwise going to be happening with Rubin, as opposed to please get this at some point in the next couple of nights. And one thing that does for all science cases is that if our envelope is limited, and we know that it is, by making these things part of wide, fast, deep, it reduces the time that you need in order to execute your search. So this is, again, I'm saying this now because we're looking at the neutrino slides, but this is true for, GW, if it's by the 4th day or something like that, all of these things. I think you can get it done as part of the normal survey with just slight reworking of priorities.
So we noticed that Stephen has a question online, but before that, Fed has a relevant comment on what Adam said.
Yeah, that's exactly right. So the revisit time within the rolling cadence is roughly 2 days on the on portion of the cadence, and 6 on the other side. So that's still within a week. And when you do get it within the white fast deep, you will get 2 images in 2 filters already natively. So this might not even, like, if it's in the footprint, if it's in the rolling cadence footprint, it just won't even need to reweigh the survey strategy. We'll get there within a week multiple times. And if it's in the off part of the rolling cadence, it might need a tiny tweak to the feature-based scheduler, but definitely possible.
Yeah, and I just say, like, I completely agree. I think we want to make these observations minimally impactful and as cheap as possible. So as much as we can, reweight things, or just the observations are redundant because it's covered by the rolling cadence, we want to make use of that.
Okay. Stephen?
Yeah, just to emphasize Tony's point, from the perspective of the SCOC, remember, the SCOC are going to get these reports, and then we're going to have to justify this to the project. As Tony said, once you have identified it to 1 arcsecond, there is no need for Rubin to do anything. It's not a unique facility, even in the south. It really is only a 6.5 meter aperture once you've identified it. And so you'll need a really strong case of why Rubin, and it's not clear why you need it, why you need to use Rubin once it's identified. It doesn't have any unique capabilities over the VLT, Magellan, heck, if it's available from that latitude. So be careful of that, I think, in your report to the SCOC. Remember, we have to sell it to the project as well.
One more question from the audience.
Hi, this is John Bandit. So I was just thinking, the reason that we would maybe want to stick with U-band after the localization is one of the things we'd be sensitive to is shock breakout, which can last from a few seconds to days. But if it is on the few second time scale, I think once Rubin's already on target, maybe we could switch filters, and while other telescopes are slewing, get important shock breakout data.
Another comment from Fed.
Yeah, so a quick comment on that is the throughput of U-band is not as great as for the other filters, so let's keep that in mind when we think about this. And then the other comment that I had was, so you made a point on the last slide that you had about executing neutrino TOs alongside of GWs. But actually what I would like to also hear from the neutrino and GW crowds is, how do we think about prioritizing joint triggers and the sub-threshold triggers that occur in both systems separately? Because this is also something where we may want to trigger if we have a sub-threshold GW jointly with a sub-threshold neutrino and maybe a sub-threshold GRB. What do we do? How does that change the priority of individual triggers that are above threshold in the separate systems? So if I understood that point, you were talking about like disjoint.
Yeah, I was talking about unrelated. So I'm trying to, how do I be diplomatic about this? If there is a high energy neutrino coincident with a gravitational wave sky map, that's extremely exciting. If there is a low energy neutrino, like a subthreshold neutrino coincident with a gravitational wave event, I would need to know what the false alarm rate for a coincidence like that is. And I think at present, IceCube does not release that information. And so at the present time, I would not say it would be worth triggering, but I think there are plans to eventually do this to quantify more clearly so that you can easily pass it. I mean, I think we all understand, right? If a joint detection comes out and we see it 1 in 1,000 years, we think this is very, very compelling. And if it's 5 a year, we think it's less compelling. And I cannot anticipate exactly what the quality of future alerts will be, but that's, we should keep an open mind, but I think we can't be more concrete at this point.
Okay, so let's thank Robert again. And in case there are more questions regarding the previous science cases, hopefully we'll have some buffer time at the end that we can use for that scope, but I would try to finish the talk sooner, especially to favor those online. So the next talk, I think, will be given by Tim. Is that right? Yes. So Tim stood up and is coming to the podium to tell us about results from the discussion from the solar system object science case.
Right, yes, I'm Tim Lister from Las Cumbres Observatory, so I'm sort of doing the summary of what the sort of half a dozen or so solar system folks have been discussing. Just to sort of reorient and remind you of the sort of area that we're sort of talking about, this is again the absolute magnitude diameter versus number density plot for near-Earth objects or NEOs. And the objects that we're interested in for TOOs are the ones inside this red rectangle in the roughly 10 to 50 meter sized objects. So our work during this meeting has focused on sort of two main areas. We're trying to determine the likely rates from Rubin detections. Unlike the other science cases, we expect Rubin is going to be the majority finder of these objects in these small size things because it's just that much bigger survey telescope compared to what else we have in the NEO field. And the other area we've been working on is refining the algorithmic trigger conditions on what we might want to trigger. So on the sort of rates, there's a big thanks to Lynn Jones, who has been doing a lot of work in the background to try and figure out where our targets of this particular size are going to be coming from. So these are 30-meter objects. These are the same size objects as the Atlas survey published. They have this, what they call the candle flame plot, which shows the detectability of objects as a function of distance and as where you can look from the Earth. So the far left plot is just a semi-major axis eccentricity plot to say where the objects are coming out of. And then the blue histogram is, this is the distance from the Earth for 30-meter objects at the time of discovery, with a median of about 0.13 arc seconds, AU. So this helps us understand what the discovery time is and how much warning time we will have, and whether other facilities can do the follow-up, or whether we need to trigger Rubin. Where is the rest of the slides? Oh. Is this a different version of the presentation? Because there was a bunch of text in here that I put in here that has gone away.
Yeah.
Fresh.
So get out of.
I'm going to leave that to a Mac expert. Right.
Do you see your slides now, Tim?
Thank you. Can you get it back to full screen?
Yeah, but you see your slides?
Yeah, that's the right text.
Okay.
Right.
Okay.
Let's check. Yes. No. So we have two main science cases that have been decided on. So these are the close approaching or potentially impacting NEOs and things that are found in the Twilight survey that we're not going to be able to get follow-up from somewhere else. So either near sun approaching asteroids or rare things that we're going to lose. We've identified our source of information for the algorithmic triggers. We've verified that that's going to provide all of the needed information. We're going to be able to write a trigger for. I think we've decided upon our observation sequence. We are focusing on providing the best astrometric measurements for the arc extension. The aim of the game here is, we're trying to get more observations along the orbit in order to shrink down the ephemeris uncertainty and hopefully reduce the impact probability to zero by proving it's going to miss. We've still got some refinement discussions to go on whether a single filter is better for this purpose or whether we'd just be fine doing the regular wide, fast, deep exposures and in those filters so that the observations are just useful for the general survey and we're not poaching time out of the wide, fast, deep. Because for solar system, we want as much time as possible surveying as much sky as possible to find as many objects as possible. We did have some discussions on whether doing multi-filter GRIZ to get a taxonomy or doing a long series of short exposures to try and do rotation rates and characterization. We were told, particularly for the short exposure things, that's a very bad thing and will make the camera overheat, so we're not doing that. And this is almost certainly something that can probably be better done with other facilities. The other aspect we've been looking into is Lynn again went into the OPSIM outputs, and we have values of how much brighter the sky is than the dark sky magnitudes that are in like Igor's notebook for the twilight survey. So we know what sort of depth, because we're going to be even more background limited in the twilight survey region than regularly. We've identified a couple of issues and stresses for the RubinToO handling. So if we're trying to recover a close approaching NEO, that search area, the ephemeris uncertainty, is a function of time, and it's evolving and expanding with time. And how would we communicate that into the system so that when Rubin actually executes the trigger, it knows which area of sky to go search? The other question is, will there be the ability to dig into the pixel data inside the 80-hour limit if we get, say, TOO observations on a close approaching object, but it's below the threshold to get picked up by regular science processing? It's below the sort of 5 sigma. So that's something to think about. So the Solar System Science Collaboration, we have a NEO and Interstellar Object Working Group who are going to meet probably next week and finish up the templates. We've got quite a lot of information in the template already. And most of the points of contention have been sort of ironed out. Once we get done with that, we are going to circulate it among sort of other stakeholders. We particularly would like to get input from the existing NEO surveys that are doing this, survey and responding to close approaches, to check for additional input and check we haven't missed anything in our deliberations. And that's us.
Great, thank you. Questions? There's a question from Fed.
So you mentioned impact on the YFSD, but that's only for the IS. Am I right to think that like the NEOs are really twilight observations, so they really don't even interfere with the YFSD at all because you still want to point?
No, the majority of the NEOs are going to come out of YFSD.
Okay, so both cases would, okay. And then the other thing that I wanted to point out is that, thank you for pointing out the time variability search and pointing area. This is relevant for both solar system and GW. The GW maps also get updated. So we need to think about how to be responsive to updates of pointing areas while we're doing the TO in both cases.
Yeah, that's true. But I say, because our objects move, the ephemeris uncertainty region moves with them and also grows. So it's not a question of update, it's just a natural function of when you get onto triggering the TO on that target, you need to know what's the right search area based on, because you're searching around where the object is supposed to be.
Bob.
Thanks, Tim. Can you say a little bit more about the ability to dig into pixel data? I'm not quite sure. I know what you mean by the actual question, but what do you mean if observations are acquired in marginal conditions?
So our sort of thought is, so if a TO gets triggered and the conditions are not perfect, so the limiting magnitude that we reach may be shallower because of thin clouds or some other issue, then the detections that are coming out of the object may be below the automatic threshold to get picked up by solar system processing. They will.
Yeah, I guess I'm not following. Where does the initial trigger come from then?
So the initial trigger would have come, as an object that was either detected in Rubin, has gone through the.
You're trying to find the thing you found in good conditions,
Yes,
and it may be marginal conditions when you're looking for it in the next
Correct,
phase.
yes.
Got it. Yeah, we
yeah.
have been talking about this within the project, and I think there are ways to get an expert group vetted, qualified, whatever, to essentially become part of the Rubin team and get into the US data facility and be able to do these kind of things as needed.
Yeah, I understand, that there's the security considerations for this, and, we're not asking for anyone to go in there. We're raising this as that, somebody most likely within the solar system processing team may need to go do this inside the limit.
Are there any other questions for Tim? There is a question from Peter.
Just one other thought I just had for solar system TOOs. You do have to worry more about chip gaps and your object falling on bright stars. So I think for these observations, we can't just snap it and say, okay, we got it. We do need to go and, dither and then possibly come back, sometime later and dither again to make sure we get the TOO object on silicon that isn't saturated.
Yeah, that's a good thought. Thank you.
Question online?
I just to tag on to that, we would want more than one observation. We would want 3 observations separated in time. 2 or 3 observations.
Yeah, you're right, Melissa. I think, Peter's just making the point that we need to get 3 good observations. So we may need to take more observations in order to get 3 that are actually measurable without it disappearing into some bright star, which asteroids, I swear, aim for.
So let's thank Tim one more time. And the next speaker will be Graham Smith, telling us about lens gravitational wave science case. Do you have slides?
Yeah. Let's do a refresh. Do we get out of slideshow to refresh? Let's see.
Where's this? Thank you.
Yeah, hi everyone. I'm Graham Smith, and thanks to Jeff, Alex, Eric, Suhail for a variety of really great discussions in the last couple of days. And so on the first day of the meeting, I was basically telling you about how exciting the science is, but how disastrously faint these lens kilonova counterparts really are, and put these perhaps scary light curves up. And really in the last few days, we've been having a discussion that's been balancing numerous different issues in terms of what we all actually within the broader gravwave follow-up community here see as a realistic distribution of sky localization uncertainties. What is a realistic estimate of how deep we need to be in order to be sensitive to enough kilonova physics to actually make this experiment work? And also, if we're needing really deep data, then how to do this in a way that maximizes the usefulness of those data for other science interests, because I do understand that there are people who are interested in transients that are not lensed, and many of them are in the room. And if we're going so deep, this would involve stacking the data and doing kind of internight difference images. And so we want to make sure that any non-standard data processing is as realistic as possible. I had a good discussion with Eric about this yesterday. So this is just kind of giving you a general flavor of the discussions that we've been having and some of the topics that we've been trying to balance. And we've settled on a few cases, if you like, a few scenarios in which we would be keen to trigger a TOO. And case 1 is essentially where we have a single gravitational wave detection that looks and smells like a lens bounding neutron star merger, bottom line. And we have several cuts that motivate that interpretation of a new detection, and which I'm happy to talk through. But the key point in terms of parameters that many have been discussing in the last few days is sky localization. So our initial cut that says this is interesting and feasible for follow-up observations is 1,000 square degrees. Don't worry, I'm not about to say we want to go to 27th magnitude of 1,000 square degrees. Okay, also, and then in case 2, a new detection might pass all of the criteria in case 1, but not be localized to less than 1,000 square degrees. But maybe there's a previous detection in the same run that passes the same kind of grav wave and distance cuts, but also perhaps wasn't localized to 1,000 square degrees, but the intersection of the sky localizations is less than 1,000 square degrees. And so that's really the case 2. We haven't discussed case 3 to any great depth, but there is the possibility of basically matching all of the new grav wave sky localizations that are coming in, see what matches our kind of astrophysical cuts, and then matching with subthreshold detections from previous runs. Overall, in terms of time, we're looking at, as you'll see in more detail in the next few slides, we're looking at 3 epochs that are each taking an elapsed time of no more than 5 hours. And so just like to get that out there up front, just like on, I've forgotten what day it is, there've been so many meetings Monday. Just like on Monday, our total time envelope is looking at no more than 15 hours per trigger. So if we, at the edge of our selection criteria, we have a sky localization of 1,000 square degrees, then this is basically in a regime where we will be sensitive only to 1708, 17-like kilonovae. It's like a threshold at which you would do this experiment, right? And that more or less matches 1,000 square degrees. And we will be looking at 3 epochs as outlined on Monday, 1 very quickly, 1 a night later, and 1 about a week later to check that anything that's new and faded fast still isn't there. In this case, we will be looking to do 143 pointings in G and I. So we're splitting the time into 2 filters now. And we would reach these sensitivities. And this is about 60 seconds per pointing per filter. These depths are not as deep as I was outlining on Monday. And that's because of the larger sky localization, envelope of 5 hours per epoch. And in this scenario, being realistic about the physics that we can probe. And if you do the arithmetic, you get to about 15 hours. And why we switched to 2 filters, many of you may have read ahead already. This is to basically help people with science interests that are not lensing related, where that color information is potentially very helpful if people are interested in these grav wave detections, but think, hey, that's interesting me, even though Graham and his friends are super excited about maybe it's lensed. Okay. And also we would be, in terms of data processing, we'd be very keen that even if, say, well, basically we would like to match one exposure in this and any observing strategy to have the same duration as was being used for either wide fast deep or, say, just a regular BNS follow-up TOO, so that the basically alerts can be pushed to the brokers that are just in the regular data processing. So there's no AP, so there's no need. It's not that everyone is reliant on non-standard data processing to get something out of the data. The next slide is basically the same structure and looks at 100 square degrees. I think the broad point here, hopefully people will have got by now, is that as we have a better and better localized candidate, then we can, within our 5-hour envelope per epoch, we can go deeper and deeper and be sensitive to a broader range of kilonova physics in terms of the lens counterpart. There is a limit to that, of course, but we haven't explored the limit in any detail. But if we've got a 10 square degree sky localization, then potentially we don't need to use all 5 hours per epoch. The chance of that happening is quite small, but obviously there is a limit to this argument. And we'd stick to essentially the same. So this is at the 100 square degree level, just to give you you've got two different scenarios here, but we want to basically be scaling things more continuously than this. But this will be going deeper, 600 seconds per pointing, and again satisfying this no more than 5 hours per epoch. Okay. Data processing, as I've alluded to, well, we both want to take some of the data in a way that allows regular alert production to happen. Yeah, so that's the first point. Second point, in terms of the core kind of data processing that we would need for this particular science case, this is basically stacking many exposures on a given night and doing difference imaging between those nights, and chatting with Eric, hopefully phrase this in a way that is compatible with our discussion. Eric, it's plausible that could be done by the project, but there's just no way that can be guaranteed at the moment. So we've considered the worst case scenario, which is that let's just imagine a universe where the project aren't able to do this for us on a timescale of 05. Then it would harm the science, but it would not prevent the science if we had to do it on a local machine, local cluster after the embargo. That's because these things are so faint, they fade so fast. We've got to wait a week for the third epoch in order to actually see something that we're confident in. And if we've got to wait an extra 80 hours on that, there's still plenty of time before it's faded from view with in the observer frame K-band. And the confirmation, the amazing confirmation will be coming from a JWST follow-up timescale of up to a month. So we can do that non-standard data processing ourselves, and we've got building experience working with Eric in commissioning. We're building the expertise within the Strong Lens and Science collaboration, so that will be straightforward for us to do. We've got a reasonable draft of some sections already, and aiming to have a mature draft by the end of next week, latest. Depends how much is on my plate waiting for me back home in Birmingham next week, but pretty confident that we'll have that mature draft by the end of next week, and we'll get it out to this community and others. Some specific points. We're very keen to make sure that this is really hanging together with the other GW follow-up cases. So, these time estimates are based on my own estimates. I want to check that they're consistent with what Igor and others are doing on the non-lens side. Check the rates of mass gap detections with the calculation Schroeder's been doing. Potentially, I don't want to make too strong a statement about this, but we are also in parallel having discussions about outside of 05, a scenario where we follow up overlapping Fermi detections of short GRBs that might be lensed short GRBs. If Swift then didn't get a localization very quickly, I think there's a pretty strong case, both scientific and technical case, to then try to find the lensed afterglow with Rubin. And I think those TOs would not be as costly as these. Yeah, so I'll be on leave just after Easter. It'd be amazing to get comments from everyone while I'm on leave. And then we'll organize some kind of Zoom call about a week before the deadline for pulling this together to chat and benefit from everyone's input. I hope that's a useful summary. Thanks.
Thank you. Any questions for Graham? Pat, could you please check online? Well, in the meantime, Adam Miller, please go ahead.
I missed this, Graham. Sorry. What did you? And I know you said you're going to check the rates, but what are you estimating as the rates of events that will have mass gap during 05?
Our current way of estimating those rates is basically scaling up from the volume that GW detectors are sensitive to run by run. And there were around a handful in 03. So you could scale up. That was not paying attention to sky localization uncertainty, right? So you can imagine that number scaling up. I could do the mental arithmetic, but I won't do it on the fly as to how many there may be in 05, and then say, you know, a fraction of those being localized well enough for this to work. So that describes the algorithm, but I don't actually have a number stored in my head. As soon as we realized, was it yesterday, that Shreya could do some calculations that can help us, I thought, what Shreya's doing is far more sophisticated than my back of the envelope.
Okay, thank you.
Yeah, just to briefly add to that. So EM-Bright, the EM-Bright code has ability to generate these probabilities. So it's possible to do this for the 05 data set. But in addition to that, the 05 data set also has the masses for the sources. So we can also, we can also check consistency based on the mass ranges that you would expect for the Haas-mass gap.
Great, thanks.
And for the people online, this was Shreya and Fed. Okay, Stephen has a question online. Please go ahead.
Yeah, as we've discussed, Corinne, did you make any progress on thinking about the contamination of the low redshift, you know, well, the real mass gap objects versus your higher redshift lens, kilonova or binary neutron star merger events, and how you can work out which are really foreground and which are the lens candidates?
I think the not much, I think, is the short answer. I think the distance cuts that we've introduced go some way towards that. So these a low latency distance inference by LIGO, where they assume a source is not magnified. Basically, the lens population are predicted to have a mu=1 assumed distance of in the range 300 megaparsecs to 3 gigaparsecs. So I think that cut will help. I think our main argument would be that it's just the broader science case of following up objects in this regional parameter space deeply and quickly to see what they are is very strong. Yeah.
We have a question from Jeff.
Yeah, this is Jeff. Just to add to that, I think your concern was, what if this isn't lens and it's actually a NSBH event? Well, then the data that we're gathering in the way we're gathering would then search for that. So does that help solve the problem?
Yes. Yeah.
So this was a comment and agreed by Graham and Stephen. Do you have any comment, any further reply to that?
Yeah, I guess, I mean, are there so how can you tell that it is if so not NSBH, but in mass gap, if they both really are like black holes and they're relatively close, how do you distinguish between those? Certainly if you have a counterpart, you can, but I guess it's the distance that LIGO that they're returning that gives you some hint that it can't be, that it's going to be.
No. I mean, are you asking how do we distinguish at the stage are we selecting a GW detection to follow up?
Yeah, to trigger, yeah.
So I think, I mean, this is part of the ongoing story with the Grab waiver community, or rather, LIGO Virgo Kagra management as to what information they're prepared to release with low latency. So, I mean, nobody makes any promises as to whether they'll expand that information in the future, but there are specific parameters that they could release that would help this enormously. And I think the lensing invariant quantities are very helpful here, particularly NSBH, the mass ratio. So if they were to release in with low latency the mass ratio, that would be hugely powerful for eliminating from preventing us from following those up with these observations. Yeah.
Federica has another question.
Yep, maybe I kind of expected that there would be maybe a downscope strategy of this that only looks where we know that there are lens systems. So how complete is going to be our understanding of where lensing systems are bio-5, and would it make sense to just observe in some cases only those areas?
If I understand your question right, it's probably so that if you think there'll be of order 100,000 strong lenses in the sky, then we've got more than one strong lens per square degree. So yeah, in this very wide field Rubin era, it doesn't make sense to let your knowledge of the lens population drive the telescope.
And I have a brief question that maybe you touched upon in the last few days, but I would like further clarification. If you're concerned that the image subtraction and detection pipelines will be able to find a source with good real bogus classification, if the separation between the images of the lens transient is large enough to basically whack the possible PSF, assuming it is a point source, but not large enough to detect it as multiple separate images, say more than 1 arcseconds apart.
Yes, so I think the main answer to that is that we're collaborating with Eric and people in the difference image analysis science unit to actually do those tests now in commissioning, and then do them with now doing it with precursor data, then doing it with LSST data and commissioning and early operations. So we'll have a pretty good handle on that by that time, and we have some contingency plans as well. If we found that there were regions of parameter space that we can't control for within a moderately tweaked AP. So yeah, it's a thing, but we're not worried about it because we're on it.
Great. Any more questions from the room or from online for Graham? If not, let's thank Graham again. We still have 5 minutes before lunch. Yes, may I? So Raf has a scientific question to pose.
It's not about lunch. That's what I was about to say. So I just wanted to go back to the possibility of using TOs for poorly localized short GRBs, because that's a scientific case that we have not discussed. And so I just wanted to hear the opinions of people, and yeah, so have a discussion, 5-minute discussion about it.
There is hands up from Adam.
In my opinion, I think one of the most compelling arguments for this would be as a way to test the TOO mode in advance of O5 starting. But that might also mean one trigger, and then if it works, we say we're happy. I think that some of the points that Stephen raised previously about the fact that there's very little we can know about an event from the gamma rays alone makes it hard to say that this is an exceptional event or this is very unusual. And then the things that tell us those things often mean the localization has been found by someone already. So that's my opinion. As you said, the floor is open.
Shreya.
Thank you. So maybe one subset of this could be gravitational wave events that we may not normally consider in our triggering criteria, but that have some coincident GRB that is poorly localized. So maybe this would increase the how compelling that trigger might be.
Could you please add that?
And this is
to the
Freya
document?
speaking, sorry about that.
I think we should absolutely make a note about that. So if you can please edit the document directly,
Yeah.
That would be appreciated. If I may ask also another more question, say to Raf in particular, or anyone else who has knowledge about it. Remember a little bit kind of what our boundary conditions are. We need a poor localization to be maybe poorer than several arc-minutes, I would imagine, or how do you envision it? Or even many square degrees. So to your knowledge, what will the gamma ray facility be, or in the X-rays that will provide this sort of poorly localized triggers?
The wrong person to ask that question, so it depends what NASA will do. But and what I was thinking about is a GBM like localization, not so those are really poorly localized things. And I know within CTF, you guys have been following up this type of triggers and successfully found some afterglows, not for short GRBs, as far as I know, for long gamma ray burst. But I think that since we are in this regime of starvation of counterparts, I think it would still make sense to exercise the system, as Adam was saying, before 05, trying to go after maybe short GRBs, GBM, or whatever is going to be there giving us triggers in the high energy skies. Yeah.
Thanks. And it also sounds like Einstein probe now is particularly relevant for this type of searches. There are a couple of hands up. There is first Stephen online, and then Fabio here in the room.
Yeah, I would agree with that. I think testing on the GBMs would be really useful because it's a complex thing to do to put all the pieces together. And as Adam and Raf said, that's quite a good test in advance of, because 05 won't start until 2027. We wouldn't want a lot of time. I guess we would probably be happy if the project said, you got to take it out of your 3%. I guess we'd be happy to take a little bit of that to do the test, end-to-end test. But I think that's exactly right. We should do at least one or two tests to see that it works end-to-end.
Hi, this is Fabio. This is just a clarification that I want to ask about what Shreya was saying before. Are we thinking just to trigger a GW plus a GRB, or also if we have just the GRB, that the short GRB that we expect to have like a kilonova counterpart? That's what I'm asking, because it wasn't clear to me from the comments that Shreya said before.
My personal understanding was that we should take into account the presence of a GRB during gravitational wave events when they are issued, but at the same time we can do follow-up early on, even before, well before 05, on GBM or other type of gamma ray telescopes that have that can release poorly localized events. We haven't actually talked about exactly what type of GRB. I would imagine a lot of people in the room are thinking about short duration GRB or long duration, which are possibly coming from binary star mergers. But I also, if I remember correctly, there are people that on Slack and in other forums have also made arguments for exceptional type of long GRBs. For example, those exceptionally bright that can be, you know, not one in a lifetime, but rare enough that may be warranting some follow-up. And I think there is a comment or a question from Mansi online.
Yeah, I just wanted to add that having done GBM follow-up with ZTF for many years now, this is not for the faint of heart. The localizations are not in the hundreds of square degrees, they're usually in the thousands of square degrees. So it's the question is, I mean, and also, I mean, the way the afterglow science works, I mean, you really need to be on target on the pronto, otherwise it fades like a power law. So it is harder in some sense than the 05 game that we have been discussing. I mean, if people are up for it, I think that's great, but I'm not sure the Rubin community has this sort of, risk appetite. And, if you say thousands of square degrees, I don't know if the SCOC will just laugh it off or even consider it, right? I mean, I think that's sort of the question. I mean, What I can offer is that I have a postdoc, Tomasa Ahumada, who can pull the histogram of what these localizations are like, and maybe Rubin can do one a year or something, but of the best one. But if you want to do that, then I don't think you have the luxury of saying, oh, we'll do this one, but not that one, or we wanted to have this property versus that property. Because if you want it to be below 1,000 square degrees and accessible by Rubin immediately, then there's not that many to choose from. And the Einstein probe localizations are actually quite good. There are several arc minutes. I don't know if this has been said already. It's not something that Rubin needs to bother with its 10 square degrees. So the GPM is certainly, it's almost a bit too large for Rubin, but maybe the tail of the histogram, there might be some interest.
Thanks, Mansip. So we're almost at the top of the discussion session. I suggest David to have the last comment or question, and then Alessio and whoever else have other comments, save them for the final bit of discussion after lunch.
This is Dave from Arizona. Just one more, you could imagine a fully localized GRB with a sub-threshold gravitational wave event.